This video will cover section 3.1 on graphing quadratic functions. Now we've already talked about graphing quadratics in chapter 2 section 1, where we simply looked at a quadratic that looked like this, something similar to this. So every quadratic that we graphed in that section, the vertex fell on the y-axis. Alright, but we're going to do a review of what parabolas are. Alright, they are symmetric with respect to a line, and this line is called the axis of symmetry. So remember, we talked about this, or otherwise known as the axis, and this axis of symmetry intersects the parabola. And so our parabola is either going to be opening up, the vertex being the lowest point, the axis running through that vertex, or our parabola may open down, the vertex being the highest point, still the axis of symmetry running through that point. So remember, we said the axis of symmetry says that what's on the left side of that line and what's on the right side of that line are exactly the same. They are symmetrical. Alright, now to know when the vertex is going to be at the bottom or when the parabola opens up, you look at the leading coefficient, that number that's in front of x squared. Remember, we said a is in front of x squared always. If it is positive, then your graph should open up, and if your a is negative, your graph will open down. Alright, remember, when we talked about it in section 2.1, we made us a table, and the first thing we found was the vertex. So if you will do that first, find your vertex first, then it's a lot easier to get good points where you can get a good sketch of your graph. There are other ways that you can graph these quadratic functions, and that is by completing the square and getting it set up in a vertex form. To me, this is just a little bit easier, so I'm going to go with this way. Alright, so the first thing you're going to do is find the x coordinate of your vertex. And we do that by saying the opposite of b over 2 times a. Then we plug that back in to our function to find y, or the value of f of x. Once you find the vertex, you're going to choose 2 values to the right of the vertex and 2 values to the left. You want to make sure that these 2 values to the right and left are the same distance. So whatever value you pick first to the left, you pick that same distance to the right. Alright, and I'll show you what I mean by that. So in the ones that we did originally in 2.1 like this, our vertex always came out to be 0, and we picked -1 and 1 because they were the same distance. And then we only needed to fill in one of them, remember, and we got the exact same y value. And then, because they were the same distance from the vertex, and then we picked -2 and 2. We only needed to plug back in one of them because they have the same y value. Any numbers that are the same distance from the vertex have the same y value or the same f of x value. Alright, so let's take a look at that. Looking down here at the very first one, we want to graph it. We want to graph x squared plus 4x minus 4. So the first thing we're going to do is find the vertex. So what I'm going to do is find the x coordinate first. Alright, if I look at my function, a equals 1 and b equals 4, and that's the only 2 that I need. I don't need c, so just a and b. Alright, it says the opposite of b, so my b is positive 4, the opposite of that would be -4. 2 times a is 1. That would give me -4 over 2, which is -2. I'm going to put that right here in the middle of my table. Alright, so my vertex, the x coordinate is -2. What I'm going to do is pick values to the left and right of that are the same distance. So if I think about what number is 1 to the left of -2, that would be -3. And then what number is 1 right of -2, and that would be -1. So that these 2 values here, because they are the same distance from -2, they should have the exact same y value. So I only need to plug in one of them. Then if I think about what number is a distance of 2 from -2 to the left, that would be -4. Alright, and then from my vertex 2 to the right would be 0. so that this number and this number are the same distance from the vertex. They should have the exact same y value, and that is due to the symmetrics of the parabola. It is symmetrical. So anything that is the same distance from the vertex should have the same y value. They should match up on side to side. Alright, once you find your x values, then you simply plug them in to the original. So I'm going to find f of negative 4 by filling in. Make sure when you fill in a negative and you're squaring it that you put it in parentheses in your calculator. Alright, so when I fill in negative 4 in my calculator, I want to square it and make sure that you put it in parentheses. So that's going to be 16 minus 4 gives me negative 4. So I'm going to come up here. So when x is negative 4, y is negative 4, and that would be the same for 0, because these two are the same distance from the vertex. They have the same y coordinate. Alright, next I'm going to fill in negative 1. And you can fill in either negative 1 or negative 3. It doesn't matter which one you fill in. So I'm going to say negative 1 squared plus 4 times negative 1 minus 4 will be 1 minus 4 make negative 7. So that means negative 3 and negative 1 both have a value of negative 7. Alright, and then lastly, I'm going to fill in negative 2. So when I filled that in, that'll be negative 2 squared plus 4 times negative 2 minus 4 would give me 4. 4 minus 4 is 0. And then 4 times negative 2 is negative 8. That would be negative 8. Alright, now usually what I like to do is graph the vertex first. Alright, so I'm going to go do that. So I'm going to go left 2 and down 8. Alright, then I'm going to look to see, is my parabola going to open up or down? And the way that I tell that is I look at this number here. If it is positive, my parabola should open up. So since this is a positive 1, my parabola should be opening up like that. Alright, so I'm going to graph the other points. If you think about that axis of symmetry, alright, it is running through here. Alright. So if I take and I graph the point, let's do negative 1, negative 7. I'm going to go left 1 and down 7. Alright. That point is a distance of 1 from that axis of symmetry. So there is a matching point that is a distance, that same distance to the left. So from here, if I go 1, then I should be able to go 1 to the left and have a matching point. And I'm going to verify that. I should have a point at negative 3, negative 7, which you see I do right here. Alright, so that's another way you can graph the points also, is if you know 1/2 of them, then you can easily find the other half by counting back to the axis of symmetry and continuing that same distance. So let's try another one. Let's do negative 4, negative 4. So I'm going to go left 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. Alright, and I could come and graph this other point 0, negative 4, or once I get this point, I count back to the vertex. So 1, 2. Alright, I've gone a distance of 2. Now I'm going to continue another 2, 1, 2, and put my dot. Alright, notice this is at, I didn't go any left or right, but down 4, that is that point here. So you have two ways that you can graph them. Alright, you can do half, alright, one side, and then count back to that line of symmetry, whatever distance this is, continue that same distance. So now I'm going to connect my dots. Alright, let's look at the next one. We have negative 3x squared plus 24x minus 46. Alright, the first thing I'm going to do is find my vertex. Alright, remember the vertex, we'll write it up here. The x coordinate of your vertex is negative b over 2a. Alright, in this equation, a is negative 3 and b is 24. Remember, a always in front of x squared, b always the number in front of x. So for my vertex, I'm going to do the opposite of b. So the opposite of 24 is negative 24. And then 2 times negative 3. Alright, negative 24 divided by negative 6 gives me a positive 4. I'm going to put that right in the middle of my table. And then I'm going to choose points that are the same distance from 4, moving to the left and right. So what I mean by that is, if I have 4, if I move 1 to the right of 4, I'm at 5. If I move 1 to the left of 4, I'm at 3. So these 2 points right here should have the same y value. I only need to fill in one of them. Either plug in the 3 or plug in the 5 to get your 2 y values. Alright, from 4, if I go right 2, I'd be at 6. And if I go left 2, I'll be at 2. And so these 2 values should have the same y value. I only need to plug in one of them. Alright, this time I'm going to start by plugging in 4 to find the vertex. So I'll say negative 3 times 4 squared plus 24 times 4 minus 46. That'll be negative 3 times 16 plus 96 minus 46. Now, at any point in time, feel free to use your calculator, and what I would do is just that. I would type in my function. Alright, now don't look at the number that it's going to tell me, okay? Just ignore that value. Alright? So what I'm going to do now is I'm going to store in 4, like I did here. So I'm going to say 4, store it in x. Alright, and then I'm going to recall my function by doing second and enter until my function appears on the screen, and there it is. I'm going to hit enter. Alright, so what that tells me is when I plug in a 4, which is what we've done here, I get 2. Alright, and we can see that if we had negative 48 and negative 46 is negative 94, plus 96 makes 2. Alright, so whatever way you want to plug them in, perfectly fine. Just make sure you're showing me on the test what you're doing. Alright, so next I can either plug in 3 or I can plug in 5. I'm going to go ahead and plug in 5. So I'll have negative 3 times 5 squared plus 24 times 5 minus 46. Using my calculator, I'm going to store 5 in x. Using second enter, I'm going to recall my function. When I see the function, I'm going to hit enter. Alright, and I get negative 1. Alright, so that means when x is 5, y is negative 1, and when x is 3, y is negative 1. Let's see, we got 2 there. Alright, lastly, I'm going to fill in f of 2. So I'm plugging in a 2 everywhere there's an x. Using my calculator, I'm going to store 2. I'm going to recall, and I get negative 10. Alright, now this time when I look at A is negative. That means my graph should be opening down. Alright, so that means my vertex should be the highest point on my graph. So I'm going to graph it first. So I'm going to go right 4 and up 2. Then right 3 and down 1. And right 5 and down 1. Then right 2 and down 10. And right 6 and down 10. And then I'm going to connect my dots. Notice that my parabola is opening down. So for the test, what I'll be looking for is for you to write at least this much information, and then you can use your calculator to tell me this value.